so let's continue for the discussions of the trial paper questions, which is for this chapter is the Form 4 chapter 5, which is the chemical bonds. Okay, so let's continue with the question. So this is the question that shows the electron arrangement of the element Y and Z. Okay, so given the element Y has the electron arrangement of 2.4 and we have the element Z which is it has the electron arrangement of 2.6. So what is the formula and the type of bond formed from the reaction between Y and Z? Okay, so in the valence electron show for this element, it has 4, right, for Y. So the valence electron for Z we have 6. So it means that this is actually come from the group 17. Meanwhile, for this element Z, it comes from the group 16. So we know that actually for the periodic table, right, we have this group 14 and group 16 as the non-metal. So the reaction between non-metal and non-metal is actually a covalent compound. Okay, so they will surely form covalent bond. Okay, it will form covalent compound. So covalent compound will has covalent bond. So we can first look at the question first. Okay, the answer give us, okay, so we can cancel for the ionic bond, which is B and D, and we are going to determine the chemical formula. So Y is actually 4. Why 4 is because it still lacks 4 to achieve the stable octet electron arrangement. Meanwhile, for the element Z, it lacks 2 valence electrons to achieve the stable octet electron arrangement. So when we want to get for the chemical formula for a compound, we basically just need to cross the charge, which is we copy down first the Y, and then copy down the opposite charge, which is from the Z element, and then copy down the Z, and then copy down the opposite charge of the element Y, which is 4. So 2 and 4 actually can be divided by 2, which we can simplify it, right? So 2 divided by 2 is 1, and then Z, which is 4 divided by 2 is 2. So the answer would be YZ2, which is A, the covalent bond. Okay, next question. So this question gives us the diagram for which shows a product formed between the element Z and oxygen. Okay, we know this is actually oxygen, but Z we don't know what is the element. So what is Z? So actually, if it is very obvious, right, they are through this overlapping region actually show us that they get the electron by sharing of the electron. Okay, so basically it is just the covalent compound. So in order to get the covalent compound, it must be through the sharing of electron between the non-metal with the non-metal. So we want to find non-metal, which is one non-metal is actually referring to the oxygen already. So this element Z is actually a non-metal. So A, B, C, D, C and D for sure will not be the answer because they are both metals. And we know that the hydrogen will only has 1 electron if based on the periodic table, right? So it is not possible for it to have the electron arrangement, which is 2.4. So it is actually the carbon Okay, next question. The table below shows the electron arrangement for the element R and S. What is the formula and the type of bond in the compound form from the reaction between the element R and S? So let's look at the electron arrangement for R. So it has 2.4 and S we have 2.8.7. Okay. So actually 2.4 is the carbon, right? Okay, if based on the periodic table, 2.4 is for the actually shows that it is carbon, and then 2.8.7 is actually referring to the chlorine because it has total number of 17 in is for the electron. So this is actually chlorine, and we know that the combination between carbon and chlorine, because they are both non-metal, so non-metal react with non-metal will form covalent compound. So this is actually a covalent compound that has the covalent bond, and we can now already cancel out some of the options, which is C and D. So next we are going to determine for the chemical formula. So the answer would be R4S1. So the reason why it is so is because this carbon is still left 4 electron left to get its stable octet electron arrangement. Meanwhile, for chlorine, it has 7 electrons in its valence electron shell, and it still left 1 electron to achieve stability. So we can just cross the chemical formula and then copy down the R, opposite charge of it, copy down the S, and copy down the opposite charge of the R, which is 4. So our answer would be RS4, which is B. So this is how we get the answer. Okay, next question. Diagram 3 shows the standard representation of the atoms of the element X and Y. So we have this as 6 and 8. Which of the following? So the reason why I actually look at 6 and 8 is because it is the proton number. And we know that the proton number is actually tell us the number of electrons. So next, which of the following are correct? Describe about the formations of compound in the 2 elements. So this is actually, if you write out the electron arrangement, which is 2.4, and then for Y is 2.6, we can just ignore the upper part, which is because it is the nuclear number, which tells us the number of neutrons and protons in it, but actually we just want to know what is the number of the electron, so we can just focus on the proton number. So actually this is a carbon. Actually X is the carbon and Y is the oxygen. So they are actually forming a compound known as CO2. Yeah. Okay. So actually we can just write out the chemical formula. So it is X 2Y4, and then we can simplify it, which is become XY2. So one atom X and 2 atom Y share the electrons. Yes, the statement is correct. So second, atom X release the 2 electrons and the atom Y receive 2 electrons. They are not the ionic compound. This statement is actually tell us they are the ionic compound, but unfortunately it is not. It is a covalent compound. Then because release actually means donate, receive actually means accept. So this accept and donate is actually for ionic compound. Okay, X. Also the third one. X atom and 2 Y atoms are required in the formations of the atom. Yeah, sure. X atom and 1 Y atom are required. No, it is 2 atom because here we get 2. So it means that there is 2 atom Y involved in the formation of the compound. So our answer would be B, which is 1 and 3. Okay, next question. Table 2 shows the electron arrangement of 4 atoms. Based on the information in Table 2, which pair of the electrons that form a compound that consists of the neutral particles? So these keywords is actually from the neutral particles, where it means that it has no charge. So for a chemical compound that has no charge, it is actually a covalent compound. And a quick tips to it is actually we can just focus on the last number of the electron arrangement, because the last numbers are the number of valence electrons, and this number of electrons is actually tell us that what is the group that belongs to. Okay, so let's say for atom W, it has 1 valence electron, so it means that it is from the group 1, which is metal. And then for atom X, it has 4 electrons, means it is actually come from the group 14, which is the non-metal. And then for atom Y, it has 3 valence electrons in its valence electron shell, so it is actually a metal. Lastly, for Z, it is a non-metal. So even though, like, if you don't know how to look at the number of valence electrons to know which group does these atoms belongs to, you can actually just count the number of electrons in for the atom, and then you just refer back to the periodic table. But it will take a long time, so I don't recommend it unless you really don't know. So we know that for covalent compound, it must be formed by the sharing of electron between one non-metal with another non-metal. So we can just focus our answer, which is for the Z non-metal and the X, which is another non-metal too. So our answer will be X and Z. Yeah. Okay, so next, we are going to identify which pair will produce the covalent compound. So I won't repeat again the concept that I have highlighted in the previous question. So just let's go through it fast. So copper is actually a metal. So metal will not involve in the formation of the covalent compound. So our answer will be 2 and 3, which is B. Magnesium is also another metal, which is located in group 2. Okay, next question. Diagram 5 shows the electron arrangement of atoms Y and Z. Which of the following formula and the type of bond are correct for the compound formed from the reaction between Y and Z? So this is also the same question. So we can just go through it fast, which is Y4, 1, 2, 3, and 4. And then Z, we have 1, 2, 3, 4, 5, 6, 7. We have 7. Right, we have 7 valence electrons, means that it still need 1 valence electron to get the stability. So we can just copy down it. So the answer will be covalent, and then chemical formula will be YZ4. So the answer is B. So next question. Diagram 2 shows an illustration between atom P and Q. I am in the group 14. Definitely this is linked to a non-metal group. I am in the group 17. It is also a non-metal, and it has a special band known as the halogen. So non-metal react with non-metal, it will form the covalent bond. Okay, next question. The electron arrangement for atom P and Q are 2.8.4 and 2.6 respectively. Which of the following is true for the formation of a compound between P and Q? We need to find a true statement. So the first statement, okay, so let's figure out what is the chemical formula for the electron. So we have this P, which is 2.8.4, and Q, which is 2.6. So P still needs 4 electrons, okay, to achieve its stability. Meanwhile, for Q, it still left 2 electrons to achieve the stability, right? The stability is actually referring to the electron arrangement. It must have 8 electrons in the shell. So we can just copy it down. P2Q4. You need to copy down the opposite charge for that, okay? And then we can actually simplify the chemical formula to become PQ2. So actually, Q is the oxygen. So how I know Q is actually the oxygen is because you compare it to the periodic table, okay? And then P is another compound. So we have this P react with the Q2 because oxygen exists as the diatomic molecule, and it will form PQ2. So actually we already get the answer, which is the answer is P react with Q2 form the PQ2, and 2 atom P, and the statement is the 2 Q atoms each share a pair of the electrons with the same atom P. So the answer will be A. Next, for the following question, so this is the question that asks us to identify what is a covalent compound. So the formation of the covalent compound is actually based on the sharing of electrons between one non-metal with another non-metal. So let's look at the option A, B, C, and D. So this aluminium is actually a metal, right? So it will not be the covalent compound, and it forms ionic compound. So for the next question, this C is actually carbon, and this chlorine is the halogen. So this is a combination of one non-metal with another non-metal. So this is a covalent compound. So the answer is B. But let's look at C. This Na is actually a sodium, and it is a metal, a group 1 metal. So it formed the ionic compound. Same goes to the D. This Pb is actually referring to lead, which is it is a transition element. So this transition element is also usually a metal. So therefore it will not be the answer as well. Okay, next. Which statement best explains the formation of the covalent bond? So metal atoms share. So the first one is metal atoms share the electrons with the non-metal atom. So it will not be the answer because covalent bond does not involve metal. Okay, non-metal atoms share the electrons with the non-metal atom. So the answer is B. So let's look at C and D. What is wrong with the statement? Metal atoms donate the electrons while the non-metal atoms accept the electron. This will not be the answer because as what I mentioned, the covalent bond does not involve the metal. So this statement is actually referring to the ionic compound. And A is strong for ionic compound because it is not shared, it is donate. And the non-metal atom will actually accept. So D, the non-metal atoms donate electron. Non-metal atom does not donate electron, they will just accept electron or share based on the type of the compounds that they form. And the metal atom will donate. So it just actually reverse already. So I think this video will end here, and this is all about the discussions for the covalent compounds. So I will see you in the next video.